Today we're going to cover the topic of solving inequalities. And they're going to be inequalities with quadratics, which we've never done before. We're going to use factoring and a number line, and even we can sometimes use a graph to help us solve this. First thing that we're going to do is make one of the sides to 0. And I kind of like to have it be a greater than. And what I mean by that is, in this case, I would subtract the x squared to this side so that I'll have my greater than 0. So subtracting an x squared, this disappears. I drop down the 2x plus 3. And then I have a 2x squared minus a 1x squared just gives me a plain old x squared. And then I'm dropping down my 4x. Next thing I do is subtract my 2x. And if I want, I can subtract 3 at the same time. So this cancels, I'm left with a 0. And then I have an x squared plus 2x minus 3. And I'm going to rewrite that in another direction, so it's going to be an x squared plus a 2x minus a 3 is greater than 0. So I still have the alligator eating my quadratic side. See how I have the right there. Next thing I'm going to do is I'm going to factor this. See how we have factoring the title of our topic. So I'm trying to add to 2 and multiply to negative 3. So that would be a 3 and a minus 1. 3 times minus 1, yep. 3 plus, yep, that works. So this is going to be an x plus 3 and then an x minus 1. So I'm going to show you how to solve this with a number line, and we basically say that we know the solution to this. We know the solution here would be a minus 3, would make that whole thing 0, and here our solution would be a 1 to make that thing 0. And what we need to do now is basically plug in a value in our number line and see if we get a positive or a negative. So what's a number that's in between negative infinity and minus 3? Well, I'd say a minus 4. So we take that minus 4 and we plug it in. So we have minus 4 plus 3 times minus 4 minus 1. And we're going to see question mark, is that greater than 0? So that's going to give me a negative 1 times a negative 5. And that is 5. Is 5 greater than 0? Well, yes, it is. So I am going to say that this is positive, or you could, if you want, you could give it a check saying, yes, it is greater than 0. Now we need to choose a different value that is in the following interval right here. And that would be, I would choose 0, but you could choose anything in between minus 3 and 1. So plugging in 0 here, I get a 0 plus 3 is 3, and then a minus 1. So is negative 3 greater than 0? No, it is not. So this is a negative, and this would not work. And last but not least, we have to pick a value here that is greater than 1, and in between 1 and infinity, so I don't know, maybe 2. So here we get 2 plus 3 is 5, 2 minus 1 is 1, and is 5 greater than 0? Yes, it is, because we get a positive. So our answer is going to be where we got positive, a positive number, because that's greater than 0. In other words, we are going to select the regions that worked. And this region worked because it was positive, and obviously we want to have greater than 0 to be our answer, and so did this one. So our answer is going to be from negative infinity to minus 3, union 1 to infinity. And it's a really important point that this is a less than symbol, so our values of minus 3 and 1 actually give us exactly 0, so these would not be part of the solution. So that's one way to do it. Let me show you another way. I'm going to go ahead and graph this quadratic, and since it's already factored, it's going to be pretty easy to graph because we know we're going to have zeros at minus 3 and we're going to have a 0 at 1. And it is a happy face because we have a positive x squared, or these are just x and x. So we know it's going to be a happy face. So where is my function greater than 0? Well, that would be where it's above the x-axis. So that would actually be here and here, which is represented by negative infinity to minus 3, union 1 to infinity. Now, if you like that method better, you certainly go for it. All right, now on this problem here, notice how it's less than or equal to 0. That's not my preference, but we're given this problem, we have to deal with it. So first is to factor it. We're trying to add to 4 and multiply to 3. So that's going to be an x plus 3 times an x plus 1. And so one of the methods of doing this is by graphing it. Well, we know that we're going to have a 0 at minus 3 and at minus 1. And we know it is a happy face because it's a positive 1 there. So my graph looks like this. However, this time I'm trying to be less than or equal to 0. So my region that is good is actually below the x-axis. So my answer here is going to be negative 3 to negative 1. And you might be saying, hey, Ms. Sorensen, why are they brackets this time? Well, because when we plug in minus 3, you can see that we do get 0. When we plug in minus 1, we do get 0. And this was that equal symbol right here, which means that we do want to be equal to 0. So that was part of the solution. Versus last problem didn't have that. So that's one way to do it. And then the other method, just as a reminder, was to draw this kind of chart. And so you have a minus infinity to minus 3. That's a little. And then you have minus 1. So in the middle of this region, we have a minus 4. In the middle of here, we have a minus 2. And here we have a 0. So plugging in negative 4, I'm just going to do that really quickly. Plugging in negative 4, I get negative 4 plus 3 is a negative 1. And then negative 4 plus 1 is a minus 3. So negative 1 times negative 3 is a 3. And is 3 less than or equal to 0? No, it's not. So I'm just going to put an x here. And that is an x because this is positive. Notice how this was a positive. Now if we plug in minus 2, and if you're saying, hey, where'd the minus 2 come from? Well, it's in between this region. I get a negative 2 plus 3 is 1, and then a negative 2 right here plus 1 is a minus 1. And that gives me a negative 1 less than or equal to 0, which is true. That works because it's a negative. And last but not least, we have plugging in 0, which is going to give me a 3 times a 1. Is that true that 3 is less than or equal to 0? No, obviously not. So that didn't work because it was a positive number. Now you don't even need to write the positive, negative, positive. You're just basically saying, does it work or does it not work given the inequality? So notice here that I have the same exact region that worked from minus 3 to minus 1. And again, I'm writing it in the brackets with closed because of this equal to symbol. All right, that's it, folks. Thanks for watching. Have a good one.